Okay, so we don't have everyone yet, so I'll mention it now, but I'll mention it again later in the class. We're gonna have our makeup quiz this Wednesday, since we had the issue last time. So I'm not gonna do any review this time because that's all we did last time. So if you wanna look at that lecture before we have the quiz on Wednesday, you can go ahead and do that. But yeah, so we're gonna finish up chapter 2. So we actually have a little more than I thought we had left. So I'm going to go through that stuff pretty fast. It's not quite as important as the stuff that we already covered in the chapter. So we're going to go through it a little fast, and then we're going to start plotting today. All right, do we have any questions so far? Okay. And I think I had a few questions last week about our project that we're going to have. So on the syllabus, I think I said that we're going to start talking about the project in week 8. So basically, we're going to finish plotting. That's this chapter we're going to cover. And then I'll assign you the project, and you'll probably have, I forget how long I said you'll have, but it'll be, a week or 2 to work on the project. And again, it's going to be like a data visualization project. So you'll have some data. I'm still thinking about what kind of data I want to give you guys, but you're going to have a data set basically, and you'll need to manipulate the data, using array operations that we've learned in the class to organize it how you need to. You might need to do some post-processing, and then you're going to plot the data. So I'll probably have you plot, a few different things, and then we'll do that. And then you're going to have to write a small report as well. But again, that's a few weeks out, so we're going to talk about it more in depth later on. Okay, so let's finish up chapter 2 now. Okay, so the first thing we're going to go over is matrix exponentiation. So last time we finished off on the slide here on linear algebraic equations for how to solve that in MATLAB. So now we're on slide 103. All right, I'm going to change this so it's the colors, right? I should make the font bigger too. Okay, so matrix exponentiation. So this is going to be pretty similar to basically just multiplying some matrix by another matrix or that same matrix. So down here, if we have a square matrix A, if we do A squared, that's the same as A times A. And if we try to raise a matrix to another matrix, that's not going to work. So let's just quickly show matrix exponentiation. Again, I want to go through this stuff somewhat fast today so we can start working on plotting. So if I have this matrix A, that's a 2 by 2. If I do A squared, then it's going to basically do A times A. All right, MATLAB has some special products. We can do the cross product or we can do the dot product inside of MATLAB using those commands. So if we have a cross product, I think everyone should have learned the cross product by now, and maybe not. I don't know. 250A, I think you learned it. But if you haven't, this might seem a little weird. So if we have two vectors here, if we have x equals 3, 9, and 6, oops, and then we have y equals 2, 4, and 6. If I want to do the cross product between those two vectors, I can just type in cross x comma y. So I'm specifying do the cross product for these two vectors x and y. And then it'll do the cross product for us. So we have our answer is going to be 30i minus 6j plus 6k. And if you need a little refresher on the cross product, I carried it out actually right here. Are you going to use that a lot in MATLAB? Probably not. I don't think I ever have. But if you want to check your work or something for your math homework, you could do that. Although there are some cases where you might use the cross product. If you're doing like, I don't know, fluids homework or math homework, you would maybe need to use that. Okay, the dot product, so might do this a little bit more than the cross product, but we can do the dot product as well. So if we have two vectors, if we have A and B, so A is 2, 3, and 4, and B is 5, 6, and 7. Then we can do the dot product between these two vectors by just using that command dot and then specifying which vectors we want to use, and that would be A comma B. Okay, this is an error right here. It should say the size of the vectors. Oh yeah, it does this. It does say that. Never mind, I read that wrong. So the size of our vectors need to be the same, but the dimensions of them don't. So here the size of the vector is a 1 by 3, and we have a 1 by 3. So I could have a 1 by 3 vector and a 3 by 1 vector. So the size is the same, but the dimensions are different. So I can still carry out the dot product in that case. So just like I have here, I have dot and then A comma B transpose. So in this case, let's actually specify it like this. So the size of A, that's a 1 by 3. And then the size of B transpose, that's a 3 by 1. So, you know, I guess technically the sizes are different, but they're compatible. You know, we're in vector A, we have a 1 by 3 vector, and vector B transpose, that's a 3 by 1. So the sizes are different, but they're compatible just because we transposed them. So if I do the dot product of A and then comma B transpose, then that's still going to give us the same answer.
Does it work as well for the cross product or just the dot?
I think it would only work for the dot product. Let's try it though in the cross product. So let's actually just use those same vectors here. Go up. Okay, if we do cross x comma y transpose, okay, that did work too. Okay, yeah. So I would just be careful with that because when we're actually carrying out these calculations by hand, we have to be explicit in how we write them out. So while it still works, you should really you shouldn't have that transposed there because if we're doing it by hand, we wouldn't have y transposed.
Okay, thank you.
Okay, and for the dot product, this is just a little reminder here that that's the same as what we did before when we had vector multiplication of a 1 by n vector and an n by 1 vector. So we could do this multiplication because the inner numbers, they match, they're just n. And then the outer numbers are 1 by 1. And since they're 1 by 1, that means we have a scalar result. So just one number. Okay, so polynomial review. So this is actually going to be a decent segue to what we're going to start doing today, which is plotting. But first we have a few operations that we can do on polynomials before we plot it. So to define a polynomial, all we have to do is just define some row vector. So if we do a equals 2, 3, and 7, that's going to be the same as a equals 2x squared plus 3x plus 7. So each of these numbers here, they represent a coefficient starting on the left-hand side, that's the highest power, and then we go down to the right-hand side to the lowest power. All right, and then if we want to find the roots of this, so we covered this before as well, but just to refresh you, I'll just do r underscore a, doesn't matter what we put there, but r underscore a, if we want to find the roots, then we use the roots command, and then roots of a, and that'll give us the roots of our polynomial here. All right, and then if we use this function right here, this poly of x function, we can find the coefficients of our polynomial whose roots are specified by some array x. So for our example here, if I just type in this variable poly underscore r, and then I use the poly function, I can find the coefficients for that corresponding polynomial. So I think it's kind of a lot to say at once, so I'm going to go over a little, I don't know, step by step. So our polynomial that we defined up top is here. It's 2x squared plus 3x plus 7. But if we didn't know that, let's pretend we didn't know that was the polynomial, but we only knew that we had the roots for this polynomial were right here. So r underscore a. If we only knew those roots, but we wanted to find the corresponding polynomial, we could use this function poly right here. So I'm going to do poly of r equals poly underscore ra. Again, whatever you put on the left-hand side here, that doesn't matter. I'm just assigning some variable, but we're using this function poly. So this function, again, it's going to give us the coefficients for that corresponding polynomial for the roots that we already know, which are right here. Okay, so if I do that, now it gives us these coefficients right here. So this is saying that we have a polynomial that's 1x squared plus 1.5x plus 3.5. So you might be thinking to yourself, well, that's different than what we defined up here. Up here we had 2x squared plus 3x plus 7. But they're the same, it's just simplified right here, where we're dividing through by 2, basically. So those are equivalent, and we can, you can just know that just from simple math, but we can confirm that by now looking at the roots of poly underscore r, because remember, poly underscore r right here is a polynomial. And then we see that the roots up here, they're the same as the roots right here. So they were equivalent. So I think that was a lot at once, but if you kind of go through it step by step, it should make sense. Just keep in mind that this function right here, poly of some array that contains roots of a polynomial, that's going to give us the coefficients of that corresponding polynomial. Okay. So polynomial addition and subtraction, well, that's just going to be the same as simple, array addition and subtraction. It's going to be the same thing because we, represent a polynomial in MATLAB just by an array, by a row vector. So I'm actually not going to type this stuff out because we've covered this before. It's very simple. And again, I want to get to plotting today. Okay, so we're going to skip that exercise because again, it's quite simple. I guess I did try to have a little trick question here. So here we're trying to do s minus r. So we're trying to do 5x to the third plus 25x squared minus 25x plus 3 minus, all of that up there. If we just plugged that into MATLAB and try to do that subtraction, that wouldn't work because the sizes are different. Here in matrix or vector S, our highest power is to the third, while in vector r, the highest power is to the fourth. So we have to trick MATLAB into thinking that we basically have something that's the same size. So here I basically added a 0 to the beginning of our vector s, and then in that case we can carry out this subtraction. Okay, let's see what we got here. To multiply a polynomial, we're going to multiply the coefficient array by a scalar. So we've done this before as well. It's just scalar multiplication of a vector. And remember, that's going to go element by element. Even though we didn't specify an element by element operation here, we just have a star. It's going to carry this out element by element when we're multiplying a vector by a scalar. All right, multiplying polynomial. So here, this is going to be a little different now. So when we had a polynomial addition and subtraction, that was the same as array addition and subtraction. If we want to multiply a polynomial or divide a polynomial, we have to specify that we want to do that for polynomials. So let's type out some vectors here. We have a and b. So a is 2, 5, and 3. And b is 4, -3. Let's just clear it. Okay, a is 2, 5, and 3. B is 4, -3. Just typed again. My mic is somewhat in the way when I type, so I mess up sometimes. Okay, 4, -3. There we go, finally. Okay, so if I wanted, if we did our typical vector multiplication here, we see that we have a 1 by 3 and then a 1 by 2. So if I did a times b, that wouldn't work because our dimensions are different. We have a 1 by 3 and then a 1 by 2. So our inner dimensions, they don't match. That's not what we want to do anyways. We want to multiply our polynomials here. And that's just carrying out this operation here. So we're doing FOIL basically. So if we want to multiply these polynomials, we have to specify that we want to do that. So we're going to use the convolve function, or yeah, it's convolve, yeah. So that's shorthand just conv, and then we're going to specify our vectors that we have. In the documentation, they use the vectors u comma v, but in this example, we have two vectors a and b. So if I do that, it's going to give us the coefficients for our polynomial. So we have 8x to the fourth plus 14x to the third minus 3x squared minus 9x. Okay. Okay, we have a question, why wouldn't it be negative or 4, -3, 0? So in this case, we don't have to specify or trick MATLAB that we have the same size because we're not doing an element by element operation now. We're doing like a multiplication. We're doing FOIL, not matrix multiplication here. So we don't have to trick MATLAB for the size. Yeah, that's why if we just did a times b like we did in the beginning, that didn't work because those sizes were not compatible. Okay, if we divide polynomials, that's going to use synthetic division. I don't even know when I did synthetic division last, so actually I had to kind of look it up a little bit. But it's going to carry out synthetic division. So to do this, we have to use the deconvolve function, and that'll just do synthetic division for our polynomials. So if I have our same two vectors here, a and b, if I want to divide them, I'm going to do deconvolve and then a comma b, and then that's going to give us 0.5x plus 1.6250 Okay, so you see here, I have a different answer in MATLAB versus on my slides. So for this, we have to actually type out stuff more specifically. So here on the slide, you see I wrapped in brackets Q comma R. So that's going to give us two answers basically in MATLAB where we have our quotient and our remainder. So if I do Q comma R, and then I specify deconvolve A comma B, then it's going to give us our quotient here, which is 0.15x, or sorry, 0.5x plus 1.625, and then it'll give us the remainder, which is 7.875. Now again, to be totally honest, I haven't done synthetic division in a long time. So to actually explain the math behind it, I would have to look in my math book a little bit more again. But yeah, if you have to divide polynomials, this is how you do it by using this deconvolve function. All right, so now we're on plotting polynomials. So here, I'm actually not going to go over this right now because it's in the slides for plotting. So we're going to get to plotting polynomials at some point in time. I don't know if it'll be today or tomorrow or, whenever, but we are going to get to it. But I'll briefly talk about what we would be doing for this, okay? So if we have a polynomial here, and we want to, so in this case, we have this polynomial, and then I define an x domain from 0 to 10. If we want to find the corresponding points for y, so we can plot it, we're going to use this polyval function. So that's going to evaluate our polynomial here to look at all of our points here in x and then get a corresponding point for y. Okay, so it's going to evaluate this polynomial for those points in x. This will make more sense once we actually carry out an example, again, either this class or next class. And you see in this case, I have some points here, so it's not really a smooth plot. We could increase or we could decrease our step size to increase the length of our x domain here. And then that would give us a smoother plot. Here I used a whole different polynomial. But again, we'll get to this a bit later on, and we're going to go more in depth. All right, basics of importing data. This will also be something that we go over in more depth later on. I put the slide in here because I thought we were going to go over this last class, but last class was just a review. So you will need to know how to do this for the project. So that's, again, why I'm going to go over it more in depth later on. But if you have MATLAB 2019 or sorry, MATLAB 2018B or previous, then to import data, you're going to have to use a function like XLS read, or there should be another function called CSV read, or maybe that's just in Python. No, okay, there is. So you would use a function like that to import data, but for MATLAB 2019A and on, we have to use a new function, or it's recommended to use a new function called read table, or we could do read matrix or read cell. So to see which version of MATLAB you have, it should show on the splash screen when you open up MATLAB, but might be, I know you can check actually in here somewhere as well. I can't remember off the top of my head though. MATLAB, maybe right here. Yeah, about MATLAB. And yeah, so I'm running 2020A right now. I think 2020B just came out recently though. So anyways, again, we're going to go over this in a bit before the project. All right, so I know I went through the last part of these slides pretty fast here, but are there any general questions that you have on chapter 2 for arrays?
No.
Okay. All right, so we're going to start plotting now. So I think plotting, at least in my opinion, it's more exciting than some of the stuff we've been doing. I know all of this can get kind of tedious once we're going through like so many of these slides, but I don't know, is what it is. And I think it, it's helpful still, but I know it can get tedious. So anyways, let's get started on plotting. All right, so plotting, I think we're going to go over in about 2 weeks, something like that. It'll take us that long because there is quite a lot to plotting, or I should say there's a lot of options for when we make plots. So this will, of course, be very important as well because we're always going to be plotting data, whether it's in a lab or in some report that you're writing, or you just want to visualize some data. That's going to be pretty important. Okay, so we're going to learn how to make 2D and 3D plots. These are our overarching goals. So we're not going to do, 3D plots today. That'll be towards the end of this chapter. And then we're also going to learn how to plot multiple curves on one graph, how we can label axes, how we can make a title. We'll talk about different data markers that we can use, etc. We'll talk about how to make a legend, change colors, how to have subplots, change our axes limits, our tick labels, the angle of the tick label, the intervals for our ticks. I mean, there's so much stuff. Okay, so basic plotting info. We need to make sure that our plots have the same length, or sorry, that our vectors for the plot have the same length. So if we have two vectors, x and y, and we want to plot that, they have to be the same length, or else, well, we can't plot it. If I have some vector x, then I need a corresponding vector y, or whatever it may be. That needs to have a corresponding value for each element in that vector. So to make a plot, we might have an equation, and that's what we've done quite a lot here. So often we've done x equals 0 to 0.01 to 10. I should have said that a little differently. We are starting from x, we have a step size of 0.01, and then we're going to 10. So that's our x domain. Now I need a corresponding y domain, or we need a corresponding independent variable. So here we're going to have y equals, and we'll do sine of x. So once we have this, y equals sine of x, that's going to look at our vector x that we just defined, and we're going to make corresponding values for this vector y. So if we look in the workspace on the right here, we see that both of these vectors are the same size. And because they're the same size, then we can plot them by using the plot command. So the plot command, our first argument needs to be what we want to have on the x-axis. And then the second argument will be what we want on the y-axis. All right, so you probably shouldn't get that warning. That's just because I'm using MATLAB on Linux, so don't worry about that. It's not an issue though. And so here's our plot for sine of x. All right, so that's just the very basic gist of how we can make plots inside of MATLAB. Okay, I'll ask if there's any questions on that. I'm assuming no, but if there are, then, that's fine, and let me know. Okay.
I see if the 0.01 is in the y-axis. How can you change it to the x-axis instead of the y-axis?
I have 0.01 for the x-axis right here.
Oh, no, but I'm saying like when you see in the graphing that the figure 1, the graphing part, it
So you
says
want me to, if I plot it again?
you see that it's going 0.1 each time along the y-axis
Yeah,
versus
so
the
it's going from
x-axis.
0 to 0.2, 0.4. You're saying that, right? So our ticks, the value for our ticks, yeah, they're different. And so MATLAB does that automatically. We can specify the tick interval that we want, but that'll be a bit later on.
I gotcha.
Okay, so for an example here for what we're going to go over, if we have our just some example plot here. So we're going to go over how to make a plot title up top here. We'll go over how to specify data symbol, which is, in this case, we have circles, but we can change that to something like a square, a diamond, a star, a cross, I mean, so many things. And we can specify what kind of line type we want. So if it's a dashed line, a dash line, a solid line, a dotted line, and then we have a legend. So we'll go over that. Our labels, we'll talk about that. And then we have our tick mark labels and the tick mark. So like Joshua, I think what he was asking was how can we change the intervals that we have for our ticks. So we'll talk about that probably next class. And then the tick mark label, in this case, in this example, they're just integers. So we have 0, 1, 2, and then going to 10 on the x-axis. But we can specify if we want to have it like, I don't know, by intervals of pi, and then it would show a 2 times pi instead of the numeric value for 2 times pi. Or we can specify a dollar sign as well. I mean, again, there's so many things for plotting. Okay, so basic plotting, we already kind of talked about this, but if we have two vectors x and y, and again, they don't have to be x and y, I'm just going to use that because of convention. But our x values, they're going to go on the x-axis, and then the y values, they're going to go on the y-axis. And MATLAB is going to auto-scale the figure by default. So it'll automatically decide, let's plot this here again. It will automatically decide where it's going to stop our axes. So here we're going from 0 to 10. Of course, we specified that up here that we want to plot from 0 to 10. But if we wanted to show a range larger than from 0 to 10, we could do that. Or if we want to specify a range larger than -1 to 1, we could do that as well. Now, it's not going to plot in that range, but we could show that range in the plot. Okay, so let's do an example here. So maybe you've already done the example that I showed up here. But this will be a bit different. So we're going to define two vectors, x and y. So our x vector is going to be our x domain. And then the y vector is going to be the equation that we're going to plot. And then here we're going to make an x label and a y label, a title and a legend. So we're going to learn how to do that right here. So I want you to go through this on your own. Obviously, I showed you what to write, but I'll give you a minute or two to type this out.
Professor,
Yeah, question?
never mind. I thought we were going to do the other example, but okay.
Mm. You know what? I forgot to say something. And some of you might have already figured this out, but we need to use a script here. So now that we're in plotting, we're gonna kind of exit the command window now. We're not gonna use that as much. So we're gonna go on the top toolbar here and we're gonna click on new script. Okay, and then that's gonna open up the editor window. So we'll actually go through this as a class right now, just because I forgot to mention that. So just make sure you're in new script again. You're gonna go on the top toolbar here and click on new. We can click on this drop down arrow and click on script. Okay, So having a script, that's going to allow us to basically type in multiple lines and not have MATLAB try to execute whatever code is on that line. So let's type out our X domain here. So we're going to do 0 to 10. Then we'll do our equation here, which is 5 times x squared. And you'll also note that for x squared, I'm using element by element exponentiation. That's because we have our vector x here. And if we're raising that to a power, we need to do that element by element. Okay, then we're going to plot it. So right there, I just press enter and nothing happened. That's because we're using a script right now and we haven't run it yet. And we'll do x label, my x label, y label, my y label could be whatever. And then title, my fancy title. And then legend, we're going to specify what we plotted. So we have 5x squared. All right. So before I run this, I'm going to change the folder that I'm in right now. So I'm just, I'm going on the left here and for the current folder tab, and I'm going to go to the folder that I want for this class. Okay, so now I'm in that directory. So now if I run this code, it's going to ask me to first save the file, and it's going to save it in the current directory that I'm in. So before I do that, I want to make sure that everyone was able to open up the script file here, or that you're making a script. So were there any issues with that? Okay, so now if I click run, it's going to ask me again to save our script here. So you can call it whatever you want. Why did I think it was the 26th? It's the 28th. All right. So then if we save it, and it's going to run automatically now. And here's our plot. So all of you should see something like this right now. If you don't, let me know and then we'll kind of figure that out. Okay, I'm going to assume everyone can do it. All right.
Do we have to save it as a .m file?
Yeah, a script file should be a .m file, yeah. So, yeah, when you tried to run it and it told you to save it, you'll see that it had a .m extension here. And again, that's a script file. And then a .mat file, that's a workspace file.
When I tried running it, it says MATLAB can only run a file with a valid name. MATLAB names must start with a letter and it contain only letters, numbers. I did that, but didn't work like it.
Okay, so your file name, it has to start, yeah, like I said, with a letter, and you can't have any spaces as well. So did you have a space?
Oh yeah, I did.
Okay, yeah, so yeah, make sure it starts with a letter. And if you have a space, put like an underscore. So you can see on the left-hand side here, that's what I do for a lot of my file names.
Do I have to start all over again, retype the whole thing again, or do I have to like just edit it?
No, you can click, right-click on the file here, and then just click rename.
Okay.
And then if you run it, it should work now. Okay, so Karen says your character vector is not terminated properly. I've never seen that before. Is that for your when you tried saving it? When you tried running it? So I would just make sure that everything that you typed here is the same as I have. And if it still isn't working, then stay after class and I'll try to go over that with you. I'll have to look that up because, yeah, I've never seen that before. Anyone else have any issues like that?
Not exactly, but every time I put it to graph, the graph comes out empty.
Okay.
Oh, it's because we didn't put plot. Yeah, never mind.
Okay. Yeah, make sure you have that as well. If there's an issue here with, the online format is I can't go to your computer as easily to see what your issue might be. So if you have any issues, I would just recommend, and maybe it sounds obvious, but just make sure everything is typed exactly like I have it up here, and ensure that you're in this editor window for making a script. And if you still have issues, then stay after class and then I'll help you out. I'll be able to look at your screen then. Okay, so now we're going to do another example here. Actually, first we're just gonna, we'll do another one just right now, like a simple one. So let's define a new x domain. Let's do x equals 3 times x to the third. Or sorry, I'm doing x. So I need to define my domain. So we'll do x equals linspace. We'll do -5 to 5. And this time I'm going to specify the length of our vector to be 1000. And then we're going to define y as 3 times x to the third. It doesn't matter. You can make whatever you want to plot. So I'm writing x and y right here. And I already defined x and y over here. Doesn't matter. It's gonna overwrite that. So that's okay. Then I'll do plot x comma y, x label. So in our x labels, I didn't say this before, but for our labels, we have to have 2 apostrophes. So we're going to start it out with an apostrophe here. And I'll just call it x label. And then I'm going to close it in an apostrophe in a parenthesis. And then I could put in the y label on the same line. If I want to do that, I need to do comma, and then y label. And then I'll just call it y label. Then I can press enter. I'm on my new line. And then I can type in my legend. And yep, that's my legend. Now if I run it, so you can either go up to the top here and click on run, or you can just press F5 and it's going to run. And here's our new plot. Okay, and since we're in a script, we can actually leverage this, kind of take use of it. If you guys want to reference what we just did in class, you can do that now by saving the script. So what I'm going to do is I'm going to put a comment up top here, just so we know once we open up our file what we're looking at here. So I'll do EGME 205, plotting lecture 1, 0928. All right, so that's just a comment, and then I'm going to have another comment, clear the memory. So this was, I don't know, probably one of the first classes where I talked about this, but when we're in a script file, at the very top of the file or the script, we always want to clear the memory. So typing in clear, that's going to clear all of the variables in the workspace here. And then CLC, that's going to clear all of our text in the command window. So if I opened up, some script file, and I have those corresponding variables, if I opened up a new script file, now I would have all of those variables in the workspace. Well, I only want to look at the variables for the specific file that I'm currently using. So that's why we're going to use this clear command right there. Okay. So now we can save this file, and then you can look back on this if you want later on, and you can look at all the exercises that we worked on. All right, so again, there's our plot. Okay, so now we're going to do another plot example here, and this time we're going to have 2 curves on the same graph. So if we're, comparing something in MATLAB, and we want on the same graph, we can do this kind of method here. So what I'll do now is I'm going to use 2% signs, and that's going to allow us to have a section. I actually won't because remember in the beginning of the class I had a dark theme on, and you kind of have to do some more configuration to get everything to reset properly. But on your screen, if you weren't using a dark theme before, you could do %%, so 2% signs. And then everything after that is going to be in this kind of section here. So you see it's blocked off differently than everything else. And then I could do a new section by doing %% again. And you even see that it added a line across. So that's just to keep things kind of formatted well. But we don't have to do that. I'll just do 3% signs. All right, so I would recommend to put these comments in. So just so you can, look at your code and be able to read through it a little more easily. So I'll just call this 2 curves, 1 graph. Okay, so here I'm going to define x equals linspace, 0, 100. And again, so I have x equals linspace up here, and now I have x equals linspace down here. This line right here is going to overwrite what we had on line 7. So, I don't care what I have up here, so I'm just going to use the same variable name. All right, and then we're going to type out our equations here. So I'm going to do y1 equals 5 times cosine of x. And then I'll do y2 equals 5 times sine of x. Okay, so I want to have these two equations on the same plot. So all we have to do is plot. We have to specify our x domain. So that'll just be x. And then we have to specify the equations that we want to plot. So I'll do y1. Now if I just run this right now, then we get our plot right here. Looks pretty insane. Let's make this 0 to 10. I think that's actually what I had in my figure. So we'll do that. Yeah. Okay. So here is cosine of x, 5 times cosine of x. But if I also want to look at sine of x or 5 times sine of x, I can do that as well. So in this case, we're going to use a command called hold on. So this is going to tell MATLAB, hold on, I want to put another plot on the same graph. And then we're just going to say plot x comma y2. So now it's going to plot both 5 times cosine of x and 5 times sine of x. If I run it now we have 2 curves on one graph. So you'll see here, oops, I just closed MATLAB. Okay, so you'll see here in my code, I put hold on, but I never terminated it. So that worked, but you should have good practice here, and you should type in hold off. So whenever you're done with the equations or whatever you want to plot, you should type in hold off. That's if you're plotting multiple things on one graph. Okay, so I plotted x comma y1, and then I also want to plot x comma y2. So I'm going to say hold on. And now that I'm done with everything I want to plot, I'm going to type in hold off right there. So if I run this again, then it's going to run, and then we saw what we just saw. We have our 2 curves on this one graph. All right, so I have some more stuff here in the slides that I didn't put in yet. So if I run this again and I look at I'm going to leave it right here. So these curves, they look okay, but I personally think this line width is too thin. So I'm going to change the line width to make these curves a bit thicker. So I can do that by just going into the lines where we have plot. And then I can type in apostrophes line width, and make sure your capitalization is the same as I have here, because it is case sensitive. So I'll do line width and then comma 2. That's going to specify a line width of 2. And then I'm going to do the same for the other plot that we made, a line width of 2. Now if I run it, then the thickness of the lines got thicker. So by default, I think it's 1. Okay, now I want to put in our X label and the Y label. So I'll just do X label. So here I just put, random stuff. It's not really anything relevant. Stuff, whatever, doesn't matter. There's our X label, and then we'll do the Y label. Other stuff. All right, so there we go. And again, we can do X label and Y label on one line, or we can put them on separate lines. So I can do it like this, or I can do it like this. You just need to make sure to put in the comma. Then I can also put the title on the same line. So I'll call it the title 2 curves. Now if I run it, then there we go. We have our X label, we have our Y label, and we have the title. Now, because I have 2 curves, we should always have a legend if we have multiple curves on one graph. So we're going to type in legend, and then we're going to specify what we have. So the legend works by, when we type in the first kind of argument here, it's going to correspond to the first plot that we made. So this legend is going to correspond to, or the first argument in legend is going to correspond to line 19, where we have plot x comma y1. So it's going to correspond to y equals 5 times cosine of x. So let's type in 5 cosine of x. So that's going to be our first part in the legend. And now just have the second. It's going to be 5 times sine of x. Then we're going to close it all. Then I can run it. And here's our legend up here. Okay, so I also had more stuff. I know this is a lot at once, but this is typically what you're going to be doing for plots, so I think it's relevant. So we can also specify the location of the legend. And I'll go into more locations later on in the slides, but to specify the location of our legend, we type in an apostrophe, once again, location, and then we're going to specify that location that we want. So in this case, I could use southeast, and it's going to put it in this corner right here. So you see I can click and drag around the legend if I want to have it in a different spot as well. But if I run it right now, southeast is over here. So there's southeast, but I want southwest. So I could do southwest, and then it puts it in the southwest corner. Okay, any questions on this exercise here? Nope. Okay.
Professor,
Mm-hmm.
could I ask why for our y function we don't do the dot star for 3 times x, but we do for the exponent?
Yeah, so if we're doing a scalar multiplication for a vector, we don't have to specify element by element, an element by element operation. It's just going to do that automatically. But if we are multiplying 2 vectors and we want to do it element by element, then we have to specify it. Or if we're exponentiating it, we have to specify it.
Okay,
So I had a slide, I think last time, where I talked about the specific times when we'd want to specify it, and raising a vector to a power is one of those times.
Okay, so from what I understand, since it's multiplying by itself, that's why we would use the matrix by matrix
Element by element,
or
but yeah.
element by element. Yeah.
Yeah.
Okay, gotcha. Thank you.
Yeah, that can be I don't know, a bit confusing at first, but once you start getting more practice, it'll kind of become second nature. Okay. So in my picture here, you'll see that the legend, it doesn't have a box around it. It's right there. So we can do that as well. I think that looks a bit nicer a lot of the time. So we're going to go on a new line, and we're going to type in legend and then box off. Then if I run that, it just takes the box and it says, I don't want it, take it off. And we can have that. All right, I think I have an example coming up here. Okay, so I really talked about a lot of stuff here. So in the slide, let's okay, so in this slide right here, you'll see that my labels, they look a bit different than what we had in the slide that or in the exercise we just had. So I have this kind of formatting here where it's an actual fraction. So let's go back here. Let's pretend on the X label that is inches. So I could just do inches like that. And then let's pretend the Y label was PSI. So we're going to type in pound force divided by inches squared. So if we run this right now, it doesn't look that great. Let's do inches by inches for the x-axis. All right, so it doesn't look that great. It's not, I'm going to use quotes, an actual fraction. It's not a fraction with the numerator and denominator formatted in the way that we have it on the slide here. So if I wanted to look like that, and personally I think it looks better like that, we can do that as well. So this is not something you need to do, but it's just extra, I guess. So we can do that by specifying LaTeX formatting. So I don't know if anyone here uses LaTeX, but we can kind of have MATLAB interpret some of our text here as LaTeX. So to do that, I just want inch by inch, so inch per inch on the x-axis. I want that to be a fraction where it looks like our axis down here in the slides. So I'm going to put a dollar sign. So the dollar sign in MATLAB, that means math mode. So I'm going to put in a dollar sign here. And then I'm going to put in backslash frac, that means fraction. And I'm going to have inch. In the first set of curly braces, that's the numerator. And the second, that's going to be the denominator. And then I'm going to put another dollar sign. So within those two dollar signs, that's whatever math equation that we typed out. Then we're going to go to the Y label here. Put in a dollar sign. And then I'll do backslash frac. And the numerator, we want pound force. And the denominator, we want inches squared. And we're going to close it in a dollar sign again. And then I need to tell MATLAB how I want this to be interpreted. So I'm going to go over here again. So I'm going to actually move these on their own line because it gets kind of crowded. Now I have to specify for the X label to interpret this as LaTeX syntax. So I'll do interpreter, and then LaTeX. I don't think I need to capitalize anything, no. And then on the Y label, interpreter, and then LaTeX. So now watch our graph when I run this. Now it changed how it looked. So now I have inches per inch and then pound force per inch squared. It's a little small, so we could change the text size. We'll probably go over that later. And so here I need to wrap it in parentheses, and up here, you see that the parentheses, they're not as tall as we would like. So we need to fix that. So on the X label, I'm going to do backslash left and then parentheses. And then I'll make our left parentheses. And then here I'm going to do backslash right and then parentheses. I know this is a lot of stuff. Again, you don't need to do this, but I think it looks a bit better. So here, backslash left. And here, backslash right. Now if I run it, our parentheses look a bit better. All right, so I think that's a ton of stuff just thrown at you all of a sudden. So I think this will be a good idea for you to save this file so you can reference this at a later time. But do we have any questions on anything in this plot? Okay. I don't know if the lack of questions is a good thing or if no one was able to make the plot. I mean, you can just copy and paste what I have, I guess, but I want to make sure all of you understand what we're doing here. Okay, so we got a few questions. Still typing, yeah, so it's a lot of stuff to type. And then Karen has a question, where do we look for our saved file once we close it? So that'll be, you should make sure that you're keeping track of the current directory that you saved it in. So for me, I saved it under, it'll show you the directory that you're currently in right here. So I'm under, my grad school kind of directory. And then if I look on the left here, I can see that I have, remember I named this class example 28, and then I see it right there. So you just gotta keep track of that directory. If you have an issue, then you can, again, stay after class. Yeah, it should show the current directory that you're in on the left here. So if I closed out of MATLAB though, I'm gonna do this actually right now. If I close out of MATLAB and then I open it back up, so I closed out of MATLAB and then I opened it back up, and I'm in a different directory right now by default. I'm just in my home directory, so I would have to go back to that directory that I was just in to access that file. Or if the script is still open here, I can run it and MATLAB is going to go, hey, you're not in that directory here on the left, but I know the directory that this script is in since it's open right now. And so I can change the directory. I can just click change folder and it's going to go to that directory automatically. All right. Let's see what else we got. Okay, so now we got a plotting exercise. So here, you don't need to do everything we just did. Just make sure you can plot this. So we have, okay, so we have two functions. So make sure you can just plot y and x. So you're going to make that on the same graph. So we're going to have an x domain of 0 to 4 with 1,000 elements. And then we're going to plot these two equations here. So we have y equals whatever. I don't feel like saying it. And then z equals that. So you're going to make those plots, make it on the same graph. And
Sure.
if you want, you can do all this other stuff too, where you have an X label, a Y label, a title, a legend, and LaTeX formatting if you want. Question?
So due to like this is like a so is there a way to like keep a format and then save that format, and then when we go to like examples, and we could just go, instead of us rewriting the whole thing over again, we could just plug and chug.
You might be able to. I think that would be assigning a user-defined function. I've never done that, so I don't have that here, but if I use MATLAB inside of my text editor, then I can do it, but here in MATLAB, You probably can do it, but I've never done it, so I don't know.
Okay.
All right, so I'm going to give you guys like 5 minutes to work on this exercise right here. And a hint, you're going to need to watch out for your um, array multiplication or array exponentiation. So here, we have x squared, so watch out for that. I'll make this bigger. All right, I'm going to give you like 2 more minutes. All right, so I'm going to go over it now just because we're running low on time. So hopefully you were able to at least do most of that. All right, so I'm just going to add this below what we already have in the script. Plotting exercise slide 10. Okay. So we have to define an X domain from 0 to 4 with 1000 elements. So in this case, I don't know the step size. So I'm just going to use the linspace command. X equals linspace 0 to 4 and 1000 elements. Then I need to have a function y. So that's 8 times e to the raised to a power now, e to the negative 2x. Sorry, I should do exponent. I didn't need to raise it there. So e to the minus 2x, and then raised to the second power. And then we're going to do array multiplication. There's a lot of stuff going on here. 4 times sine of 3 times x. All right, did I type it all correctly? Let's see. Okay, so I flipped these here like this. All right, so yeah, I had a lot of not a lot, but I made this a little difficult just so you could kind of work through this array multiplication and array exponentiation. Okay, and then we have the function z equals 10 times x to the negative 0.2. All right, I'm gonna run this, make sure I don't have any errors. And then we're gonna make the plot. So plot x comma y, and we wanna hold on, plot x comma z, hold off. And we're gonna make our x legend, or sorry, x label. I'm just pretending that this is time. Y label, call this functions. Title, my title, sure. Legend. I don't feel like typing that out, not gonna lie. And we're running out of time, so legend, I'm just gonna call this Y. And then C, legend, box off. And then if I plot that, then we have our two plots here. So it's a lot to type out that equation again, but of course we could. And then we could get this plot right here. Okay. This figure should have been from before in the slides. All right, so here is our plot. Do we have any questions on this? Okay, so also you'll notice that in our script here, I have I have three graphs here, but only one graph showed up. So that's because it's overriding the previous plot. So right here, we're making one plot, so the graph would show up. But then down here, I'm making a whole new plot. So this plot here is overriding what we had up here. And this plot down here is overriding those other two plots. I could fix this by having all three of them showing up at one time. I could do that by specifying before we have plot, figure, and then in this case, I'll just call it figure 1. And then for the next one, I'll call it figure 2. And then for the third one, I'll call it figure 3. And now if I run the script, I have all three plots that show up. So here is our first plot. Here is the second plot. And then here is the third plot. All right, so that'll be useful if you want to look at multiple plots at once. All right, so we only have 2 minutes left, so if there's any questions, let me know. And if not, then I'll see you guys on Wednesday. And remember, we have our makeup quiz this Wednesday at the end of class.
Is it gonna be like the same exact quiz, pretty much, like topics at least?
Yeah, I'm probably just gonna change numbers.
Okay.
Will there be any debugging problems
No.
future quizzes?
For future quizzes, maybe.
Okay.
Hey, thank you, Professor. Have a good day.
Yeah, you too.
Professor, can I show you my screen one?